last class we have studied or we have discussed something how to draw the electronic configuration without knowing the atomic number or by only looking in the periodic table. So, for a quick revision, can you tell me what will be the electronic configuration of rhenium? Can you tell me? Hello?
Mm, Xenon
Xenon
6s2
6s2. Then the red color one.
F
That will be the
6s2
4f and 5f.
3f
3
5f
orbital doesn't have any f. Okay,
4f
4f. So 6s2, 4f,
4f 14
14. Then it will be n minus 1 no, of d,
5d5
5d,
5
5. So that's correct. And another systematic way I am telling, you just need to observe that how many element are there in period 1?
2
2. In period 2, how many elements?
8
8. In period 3,
8
8. In period 4,
18
18. Period 5,
18
period 6,
32
32. And period 7 also 32. Okay. What you need to do? If I asked about rhenium, or you know the atomic number I said of 75. Okay. 75, which is of rhenium. Okay. What you need to do? You need to add. What will be the atomic number of helium? It's 2. Okay. If you add 8 with it, the total will be 10. And that will be the atomic number of neon. Okay. If you add
okay
2, 8 plus 8 equal to 18. That will be the atomic number of argon. Then another 18. That will be the atomic number of krypton, 36. Then another 18. Okay. That will be the atomic number of xenon, 54. And another 32, not 18. Atomic number of radon, 86. So what we need to do, if I asked about electronic configuration of rhenium, which is of 75. Okay. This is the neutron number I should write in below because this top one is the proton plus neutron. So 75, you just need to look what is the prior element is of xenon, 54. Then 86 will come. So you need to only look after what is the before rare gas. It's xenon. Then you write X. Xenon, that is of 54. Then what is left? And the 75 minus 54 equal to equal to are
21.
we are taking too much time. And so you just need to divide across this 21. It's another formula. So you just need to remember 2, 8, 8, 18, 18, 32, 32. Just repeat it. Only 1, 2, then twice the 18, then twice 8, then twice 18, then twice 32. It will help you across all those inorganic problem, because it will help you to resolve what will be the configuration, how the electron are distributed across various cells of D and F. By knowing that how the electron is distributed according in the D or F cell, you can also calculate the standard reduction potential, or you can guess. Just can compare the standard reduction potential or standard oxidation potential. You can compare the atomic structure, everything. What will be the geometry of the molecule, everything you can compare. Just remember this 2, 8, 8, 18, 18, 32, 32. If I ask about the okay, I'll first clear this. It's the rule of 2, 8, 8, 18, 18, 32, 32, 32. By knowing this, if I ask you what will be the electronic distribution in my Mn, which will be the atomic number of 25. You can say means the electronic configuration, you can say by watching the periodic table or by using this 88 formula. Before 25, what will be there? The 18 one.
18.
Yes or not? That will be
Yes.
argon.
Argon.
Then this one, 4s2. Then 3. Because of the n plus L, 4 comes first of the 3. 3d5. Then the 3d5. How it will be distributed across the 5? Can say me. The 5 electron, there is 5 cell. Now, no pairing occur till everything is happily occupied. So this will be the outer cell electron. You just to find out this outer cell electron so that you can solve any problem in the inorganic chemistry. So this thing, I think the electronic configuration part you can do, or is there any doubt you can ask?
No doubt.
We need to study about various properties of this periodic table. Okay. So first thing first, the size of atoms and the anions. Okay. That thing probably you know, I think. Size of atoms. So while going through this period, the electron is going to the different cell across the nucleus. So what will be the atomic radius? How the atomic radius will vary across going to the period?
Increase.
Atomic radius increase because the electron is going to the various cells.
Cell.
It is going far away from the nucleus. So the size will be from the nucleus to the outermost electron that is situated. So that's why the atomic radius increasing going down this period. While going this way, going in this way, group way. in group 3 by adding electron, every electron going to the same 3 cell, K, L, M, N equal to 3. So by adding electron, by adding proton, everything, in this period, how the atomic radius will behave? Is there any guess?
Decrease.
Why it will decrease?
The number of electrons are increasing.
Let's guess something. Telling about some situations where this is a uh, nucleus. Okay, while going from in this direction in this group, let's say from sodium to argon, from 11 to 18, there will be the number of proton increases in the nucleus from 11 to 18, from going from sodium to argon. So the nucleus size doesn't vary much. Every proton going to the same means the nucleus size vary, but it's quite low. So just think, while going from these to these, the attraction power or the proton number of the positive charge of the nucleus increases rapidly. But all those electrons going to the same three cell. Okay, all those electrons adding from sodium to argon, all going to the same three cells. But it is not going to the above cell, but to the three cell. So the last electron, the attraction power from this nucleus to the electron, from this nucleus to the inclusion in electron very much because all is the radius is constant. Okay, the charge of this increases because the proton number increases. Radius is constant, so the attraction power is more now. Radiation is not constant means the boundary of the three cell that is constant means the electron will fill to the same cell. So, but the charge of the nucleus is increasing. So the attraction power to the electron is increasing. So gradually this cell becomes smaller and smaller because of the attraction power increases. Just remember that while going this in this group, as the proton size increases rapidly, but this all those electrons going to the same third cell. That's why the radius will decreases slowly. Okay, in these directions. There is two terms. Let's consider the there is a comparison between potassium plus and Cl minus. What will be the electronic configuration of potassium plus and Cl minus? Okay. What will be the electronic configuration of potassium plus and Cl minus? Hello.
Potassium argon 18 4s2. For argon 18 only.
Just argon 18. Or you can also say that the electronic configuration of argon. The chloride is also argon 18. The electronic configuration. So in this situation, you do not say about argon 18. You should say it will be the 3s2 and 3p6. Okay. 3s2 is 3p6. Now both having the same electron number. Okay. But the proton number or the positive charge of the nucleus, what is that? For potassium, there are how many number of proton is there in the nucleus? I think I should need to zoom
Ni-
a little. That is the 19, and the argon is the
19.
and the chloride is the 17. Okay. So potassium. hmm. So potassium. Hello. What is happening? Okay. Potassium. I think the size. Okay. The potassium having 19 proton means 19 proton. You just need to take as the unit. Okay. 19 and the chloride having 17. But the electron number is same of both, that is 18. So the electron number is 18, but there is 19 proton to attract the 18 electron. And in other case, there is 17 proton to attract the 18 electron. So which will attract more? Which nucleus will attract the outermost electron more? That magnet which is more powerful, that will attract more. This one is
Potassium
constant. So potassium will attract more. So the radius, what will be the effect of the radius?
decreases.
So what sign I will apply here? Smaller than or greater than of the radius?
Smaller.
The radius of
Cl
the
minus is
potassium is
greater than K plus.
because there is more number of electron to attract, but here the smaller number of electron to attract. In our 100%. Okay, there is. I think you can now discover or you can guess now what will be the sizes between O2 minus and Na plus. You can say Na plus and O2 minus. The electron configuration of both will be similar to neon one, that is 2p6, 2s to 2p6. But there are 11 number of proton, but in oxygen there is only 8. And you can guess the difference. From 11, it will attract to 10 electron only. But this 8 will attract the same 10 electron, but the difference here, it is 1 and it is 2. And it will lesser attracted because neutralizes, no? 8 neutralizes. So it will be lesser attracted by this nucleus. So the radius will increase vastly than the sodium. Mm, That will be the atomic radius or the ionic radius. We know now, but we're going through this period as the electron is attached or added to the different cells. So the radius increases. While in this group, the radius will decreases. And in anion and cation case, having same electronic configuration, always the cation having a smaller size and the anion having larger size. Okay. It will help you in the solid state while reading the solid state uh, to guess the radius ratios or the how will the solid state packing is there by knowing which size is more anion or cation. You always remember anion sizes are more than the cation one if having same number of electronic configurations. Okay.
Okay.
Then the thing of covalent radius. Any guesses of covalent radius? If the I am telling about who is having oxygen. Okay. O. Okay. 10 now. Oxygen. Double one oxygen. What will be the covalent radius of this? Or what will do the single bond? Only hydrogen and hydrogen. No? Okay, what will be the covalent radius? For covalent radius, you just need to check what will be the atomic radius of hydrogen. Let's say there are two hydrogen, okay, and there is bond between them, the covalent bond. But in this case, I am writing like there is a gap, but in actual, while forming a covalent bond, the spheres are closer to each other, means they can form only bond by touching each other. The nucleus could not touch each other because of the repulsion. The electron also could not touch each other, but the total atoms can. So in this case, any guess what will be the radius of covalent radius? Any guess you can?
The double the atomic radius.
Because they are closer to each other, means both having the same size. These have the
Mm.
same size, and from this to this, you just elongate this to this. So this will be the atomic radius, means the covalent radius. So 2 into the atomic radius will be the covalent radius. In case of homo atomic, means both having same. In oxygen also same case. Okay. Sometimes HCl. These are the heteroatoms. There with a bond. So in this case, you just need to add the atomic radius of hydrogen plus the atomic radius of fluoride. Okay. Here in this case, another twist because this will be not the covalent radius. This will be the ionic radius. But if you suggest, if you think as the covalent radius in gaseous state, so maybe this will be the atomic radius of hydrogen and fluoride. But these are the ionic one. In NaCl, these are not covalent. These are ionic radius. In this case, you need to add the radius of Na plus, which will be naturally smaller than sodium, and Cl minus, which will be greater than chloride because it got extra anion. Here, electron loses. You just need to add the atomic radius of sodium and atomic radius of chloride to get the ionic radius. Okay. For covalent radius, you just add the atomic radius. For ionic radius, you need to add the ionic radius of sodium and ionic radius of chloride. Okay.
Okay.
Are you understanding or not?
Yes.
Next thing, after covalent radius, we learned about this. These are the these are in the they are not reacting. They in the atmosphere they are just like same. Means neon atoms are there. Xenon atoms are there. Okay. Let's forget it. Then what will atomic radius you know na? In this direction it will increase. This thing you have completed. Then the things is Van der Waals radius. What is the Van der Waals radius? You can say means if there are two hydrogen, okay, H2 molecule, and then there are another two molecule, H2 molecule. These are not having an interaction by any means of physical bond, means ionic or covalent bond. If there are some interaction, it will be like means the London force or Van der Waals means sometimes what happen. The interaction, Van der Waals, how I'll say, uh, if there is a for organic chemistry, okay, I'm here talking about some organic chemistry stuff. Here it is a carbonyl one. Another molecule, here it will be the a alcohol one. But what happens? Due to this presence of this carbonyl, in this case a dipole will created, or sometimes by this also. In this, some dipole will create it, and there will be some interaction of negative and the positive. And there are, means some dipole created so that there will be induced positive charge here, or there will be induced negative charge here. So that's some interaction, not by any electrostatic or ionic or any covalent, but some attraction, means something is created because presence of this carbon. So these are sometimes called van der Waals forces or London forces or dipole induced dipole or dipole dipole interactions. So these are in the dipole dipole means the, this is carbonyl, this is another carbonyl. So there will be some interaction here. This will be negative charge delta minus, this will be delta plus, this will be delta plus, this will be delta minus, and there will be some interaction. This is the dipole dipole interaction. Sometimes dipole and some induced dipole is created. That is are also under the means the guidance or the under the radius of this van der Waals type of interaction. Here, you need to consider a van der Waals radius. A molecule having can be this size of the van der Waals radius, and another molecule having this size of the van der Waals radius. They are not alternating, but they have some van der Waals radius, and it will be the twice of the radius of one molecule van der Waals. Same like covalent interaction. Covalent, this will the units need to add or the double the van der Waals radius if these both are hydrogen or both are same molecule. A different molecule, you just need to add different van der Waals radius for that. This is a minor thing. I think I need to point here for any future. Do you understand or not? This just no need to remember all those things. Just to understand or get a pinch of salt from here.
Okay.
Okay.
I can understand.
Then we'll go towards ionization energy. Okay. What will be the ionization energy? First thing, energy. Ion. Pen is not working sometimes. Pen. It's ionization energy. Made of ionization. Ionization and energy. So two terms: energy, ionization. Relation you need to find means energy is required or energy will be given. So energy means some power or some external force you just give to make what? To make ionization. How a molecule will be ionized? Sodium molecule, how it is ionized? By taking one electron. Because after taking one electron, it will get a means or noble gas configuration. What it will get? To neon. Okay. Neon color configuration. How a chloride will be ionized? By giving one electron. Okay. So here in this case, we thought about ionization energy. Here another term is given. As the electron is added to the chloride, here some energy is released. It is sometimes termed as electron affinity. Or any other term you remembered, you can say me. What will be the by adding electron? What that term? Some energy is released. That will be the electron affinity. Okay.
Okay.
But in both this case, ionization occurred. But for taking one electron energy is required. To give one electron energy is released. Okay. That's what is. That's why they are different. In this ionization is occurred, but this is termed as ionization energy. This is termed as electron affinity. Now, ionization energy by adding electron or by removing electron energy is required so that a positive ion will be created, ion positive. So in this case, hydrogen will, by taking one electron, hydrogen will be H plus, lithium plus, sodium plus, potassium plus. Okay, if electron were removed. Now you say, what will be the energy required to remove an electron? There is a nucleus. Okay, there are cells. What is as magnet? This is as iron. With increasing distance, the force decreases. Okay, so in this case, the outermost electron are far from the nucleus. So taking one electron will be easier for cesium or for lithium. You say
Cesium.
because it is too much far, means not too much, not visible to our eye also, not even by microscope also, but it is relatively far than lithium. Okay, so we have got one idea in this direction in going from one period to other period. Okay, or going down to the group. Any term you can say. Group. Group में down or period go to एक period से दूसरा period. Okay. In this, as the outermost electron are far from this nucleus, so it will more energy is required. Sorry, less energy required to take one electron from the outermost orbital. Then another case, while going along a period in this direction or from one group to other group, or you can say going along a period. Okay, what will happen?
Okay.
First thing, you just need to remember about radius, how the radius behave along a group or along a period, sorry, going from this side to this side, how the radius behave. You can say while going in this group, as the proton number of proton increases, means number of the power to attract the electron or the positive charge of this nucleus increases in this direction. So the radius decreases. We have discussed it sometime before. Okay, but here what happens? The power increases. Means the attraction for the electron increases. So more energy is required or lower energy is required.
More energy.
So in this direction, ionization energy decreases.
Increases.
In this direction, in along a group, less
Decreases.
energy, less energy required to pull out a electron. So in this direction, ionization energy decreases, but in this direction, ionization energy increases. Okay. Sometimes what happens? Now comes the exceptions. Sometimes what happens? That's the case. There is a comparison between